Hey YouTube, what's up? Thanks for tuning in. WPL C34KM, C44KM. As you know, those do come with different servos, a little bit larger servos than the other WPL and MN models and JJRC trucks do come with. They come with 25 gram servos, like this one. That's the one that comes with the C34KM, which has a plastic gear, or at least this part is plastic, and we do not know how strong it is, and it works okay. I never used it. However, I used this JX PDI 2506 MG upgrade servo, which fits perfectly into the C34KM and into the C44KM. This servo is not really cheap, about 20 bucks, and it works perfectly, but it's a little bit noisy. And now with the new WPL C44KM, they also came a new 25 gram servo. That's this one. This does have metal gear, or at least this metal crown. It works quite okay. I use it in my C44KM, with which I still didn't finish, but there are also no specifications how strong it is. And some weeks ago I found on Banggood website a new servo. That's this servo. It's called VAFRC Mini DV1410 HC servo. That's a high voltage servo. It works from 4.8 to 8.4 volts, and it shows awesome values. On 8.4 volts it has 10 kilograms of pull force, so 10 kilograms of torque, that's quite a lot. And at 4.8 volt it does already have 7 kilograms. So I had to order this servo. It's about the same price range as the JX 2506 servo, about 20 bucks, so not really cheap, but I wanted to test it. And since nobody knows the real values of the WPL plastic and metal servos, I thought, okay, I'm planning to do a big servo test anyway, actually, with larger servos, as I did already last year with this DS servo, and I refined my setup. And that's this machine, or this setup, to test the servo torque. It works awesome. I will use my lab bar supply to power the servo, use a servo tester for controlling the servo. I will use this servo arm, and the screw is exactly 1 centimeter, 10 millimeter distance from center of the servo, and that way I can really nicely check the kilograms, centimeter each servo has torque, or each servo pulls. As we all know, kilogram centimeter is not really the correct unit to use for this. The correct unit would be Newton meter or Newton centimeter, but nearly no one in RC is using this correct unit. Only some German companies do still use it, but the world is using kilogram centimeter. Even Futaba is already using kilogram centimeter. It's quite easy to calculate Newton centimeter, kilogram centimeter divided by 10, or exactly by 9.81. And there's further units that are used for servos in RC. That's the super strange ounces inch. This ounces inch is used by a rather small minority of about 4.3% of the world's population. The rest uses international values. However, calculating is rather easy. If you know the numbers, you have to multiply it. You have to multiply kilogram centimeter by 13.89 to get ounces inch. And because I do not want to discriminate any minorities, I will do this for you, and I would really appreciate if the people using those strange values on YouTube videos would do this also for those people in the world, more than 95%, who do not understand this unit, because it's really difficult to understand. most of them unfortunately not do it, and there are even some companies, for example Reef Servos, on their website. You won't find kilogram centimeter, you will only find ounces inch, what's really hard to understand. And I will not only test the servo torque, of course that's the main part of this video, but I will also open the servos and take a short look inside of each of those 4 servos, check if they are well lubricated and if there are bushings or bearings and metal gears or plastic gears, and then I will check them with a normal radio and check how fast they are, but I can't measure this. I will put them in parallel side by side with the radio, and maybe we can see if a servo is faster and the other one is slower. And what we also will check is the amp draw of this servo, because it's not only important how many kilograms or newtons or ounces a servo can pull, it's also very important how much amp it draws when doing this, because you know we use mostly rather small ESCs on those trucks, and those ESCs have BCs which are sometimes not that strong. Many of us use those small red ones, super cheap ones, work quite okay, and they do have a BC of 1 amp only, or 0.8 amp depending on the source, where you don't really find exact values. So maximum 1 amp, or the small Hobby Wing Quick Run 1625, really nice ESC, but the BEC of this is also only 1 amp, and the larger ones, they mostly have 2 amps, like this Hobby Wing 1060, so those ESCs do have BECs which can provide 2 amp, and some ESCs like the Hobby Wing 1080 do have a BEC which can provide 3 amps. And what's quite nice, when I will test the servos later here on their pull force or torque, I will not only read the kilograms the servo pulls, but I can also read on my small lap power supply the amp draw. And if the servo will draw more than 1 amp or more than 2 amp, this will be a problem if you use one of those smaller ESCs. So I will then, I don't know the results now, additionally test the pull force or the torque with 1 amp, because I can limit the amp to 1 amp or 2 amp to every value up to 5 amp with this power supply. So I will measure the maximum torque, the kilograms the servo can pull without any limit of amps. The limit would be 5 amps of this small lap power supply. However, 5 amps, hopefully none of those small servos will draw. And then if the servo draws more than 1 amp, I will test it with a limitation of 1 amp and 2 amp to show how much the servo would be able to pull with a BEC that can provide only 1 or 2 amps. And now let's take a quick look inside the servos, check the gears, check if they are lubricated. None of the servos is said to be waterproof, and if the gears are not lubricated, I will lubricate them later. That's the servo that comes with the WPL C34KM. You see, only plastic gears, no lubrication at all, and it does have a bushing. And that's the servo that comes with the C44KM. Check this out, nice metal gears and also lubricated, and a bushing in the upper part, and the JX PDI 2506 MG. You see it has a ball bearing. It doesn't seem to be lubricated, is it? I for sure will put more grease inside those. Nice ball bearings. Here's a small O-ring. Looks quite well built. And finally the AFRC, the new servo. There seems also to be no grease or nearly no grease on the gears, so the JX servo does have brass gears, and the silver ones, I don't know which metal this is, and the AFRC is said to have titanium gears, so it looks really nice inside. There is no small O-ring, however, ball bearing. Is there any lubrication? Oh, a little bit of lubrication. Looks quite good, but thumbs up for WPL for the C44KM servo. Full metal gear, no ball bearing. And now let's check how the servos work. I use 6 volt for powering the receiver. On the left side the WPL C34KM servo with plastic gears. Here the WPL C44 servo with metal gears. Here the JX PDI 2506 MG servo, and here on the right side the VAFRC Mini DV1410 HC servo. First to test if they are noisy or not, one by one. The plastic gear servo of the C34KM. How fast it is, I don't know. Not a lot of shivering. And now let's check the metal gear servo of the C44KM. It's significantly louder and seems to follow the shivering of the radio wheel a little bit more, so does also seem to be a little bit faster. And now the JX PDI 2506 MG. And you hear the noise as the one in my C34KM also emits, so it's not silent. But it seems to be significantly faster, follows the shivering of the steering wheel more. And last but not least, my new AFRC servo. No noise at all. Really very silent. And wow, can you see the difference? Okay, and now I will connect all 4 servos in parallel. And now all 4 servos in parallel. You see the JX does have reverse direction to the other ones. Hard to say which one is faster, but you can see that the right 2 servos clearly follow the shiver of the turning wheel better, so they should be faster. The 2 WPL servos seem to be exactly working with the same speed. And now I reversed the channel of the JX servo, so all go in same direction, and to me it seems the AFRC servo seems to be faster than all of the others. And the JX servo, hard to say. The VAFRC servo, if you let the steering wheel shiver, seems to wait a little bit to go to the center, while did you see this? Normal steering. And now let's start the torque tests. I will test the servos on 5 volts and on 6 volts, and the high voltage servo also on 7.4 and 8.4 volt. Here you can see the voltage. Here you can see the amp draw. I hope that's visible on camera. And here is my luggage scale that will show the kilograms the servo will pull, or the torque, on 1 centimeter distance. .99 and 1.01 amp, 3.4 and 1.0 amp, 3.4 and 0.95 amp. That's good. And now let's change to 6 volt. WPL C34 plastic gear servo on 6 volt. .3 and 1.1 amp, 3.1 and 1.1 amp, 3.2 and 1.09 amp. So 1 amp BEC should be sufficient for the WPL C34KM plastic gear servo. And now the WPL C44KM servo with metal gears, 5 volt. .4 kilogram, 1.5 amp. .9 kilogram, 1.4 amp. .98 kilogram, 1.36 amp. 6 volt. .78 kilogram, 1.55 amp. 4.9 kilogram, 1.55 amp. 4.96 kilogram, 1.52 amp. And now let's 6 volt. Let's limit the amp to 1 amp. So 6 volt, 1 amp maximum. 3.8 kilogram, 3.4 kilogram, 3.4 kilogram. You can see the 1 amp maximum here. And now the JX-PDI 2506 metal gear servo on 5 volt, no amp limitation. .67 kilogram and 1.0 amp. .5.01 and 1.05 amp. 4.98 and 1.02 amp. Good. And let's go to 6 volt. 5.4 and 1.2 amp. 5.4 and 1.18 amp. 5.32 and 1.17 amp. Okay, let's see if there's a difference if we limit the 6 volts to 1 amp. I don't think so, but JX-PDI 2506 metal gear 6 volt 1 amp limitation. 5.291, 5.14, 5.15. Good. And finally, my new servo, the VAFRC Mini DV1410 HC on 5 volt, no amp limitation. .9, 1.4 amp. 2.9, 1.3 amp. 2.9, 1.3 amp. This was not good. Let's go to 6 volt. 3.2, 1.55 amp. 3.2, 1.5 amp. 3.2, 1.48 amp. So that's really poor. Now let's check 6 volt 1 amp maximum. 2.5, 2.7, 2.87. Now let's go to 7.4 volt. 7.4 volt, 3.7, 1.8 amp. 3.7, 1.7 amp. 3.67, 1.65 amp. Wow, is this poor. And now let's go to 8.4 volts. So it's said to have 10 kilograms. 4.0, 1.97 amp. 4.0, 1.8 amp. 4.02, 1.8 amp. What a disappointment. Wow. So quite surprising results for me, at least in one servo. If I said sometimes different values or numbers than I wrote down, then that's it, because it's quite difficult to check the kilograms and the amp draw live, the highest value, and I checked it then again on the video, and the numbers I wrote down are the correct maximum numbers, the maximum values the servos pulled or drew. And here you can see the results in a table. Those values are the mean values of the single measurements. Here in the plastic gear C34KM servo did quite well, and weak BEC with 1 amp is sufficient for it. And the C44KM servo with metal gears at 5 volts it was not much stronger, but at 6 volts it was stronger than the plastic gear servo, but it also drew a lot more amps. So if you check the third part with a 6 volts and 1 amp limit, you see it's not so much stronger if you would use a weak BEC. The JX servo, the PDI 2506 MEG, it did fantastic, really. So in the brackets you see the factory data, okay, a little bit higher, but only a little bit. But best part of this, check the amp draw of this servo. It drew only 1.08 amp at 5 volts and 1.21 amp at 6 volts, and the torque was always around 5 kilograms. And even with a 1 amp BEC at 6 volts, the torque is higher than 5 kilograms. So really good. And the biggest disappointment was my new servo. I can't believe it. I probably should complain. Check the data the factory gave. 7 kilograms at 7 kilograms at 4.8 volt, and I tested it on 5 volt, 3 kilograms and 8.5 kilograms on 6 volt, and what did it bring? 3.2 and 10 kilograms at 8.4 volt, and I measured 4 kilograms only. C34KM plastic gear servo, it's quite okay, it's not weak, and 1 amp is sufficient. I don't know how long the plastic gears will hold up. WPL did a real good job with the C44KM metal gear servo, I think. Maybe you shouldn't use the weakest BEC or ESC with the weakest BEC to get the full power. And the JX servo, I had good luck when I bought this months ago for my C34KM. It does really fantastic. The only downside is it makes a little bit of noise, but if you don't care about the noise, like many Servo servo do this too, then that's a fantastic servo. And even with a weak 1 amp BEC, it will be really strong. And this VAFRC servo, I really can't believe what I measured here. It's wow. And because we do not know what all those China servos really are able to pull, or what torque or speed they have, even if the factories give us sometimes really fantastic numbers which probably nobody believes. And that's why I plan to make a servo test with larger servos too. That's why I built this. I do have a ton of standard servos for my larger crawlers here, and I searched all I had in my cars and in my spare parts, and check out for this video. It will come soon, and I'm really curious how those larger servos will perform compared to the data given by the servo descriptions. So that's it for this video. Thanks for watching, guys, and I'll be back.